Hello and welcome to this tutorial on generating temperatures live using the microbit. Prior to beginning this tutorial, you should have completed a number of steps just to get ready. So the steps which you were asked to complete are set out in Google Classroom for you. So the first thing is to connect your microbit to the PC. So I've done that. I've created a new project in MakeCode. So I have MakeCode here, BBC MakeCode, and I've created a project and its name is ALT2 Generate Data. I have no code here just yet, it's just a project ready for that. I have created a new folder. So I'm not on the school network here, but I do have a new folder which I have created called ALT2 Generated. And in that folder, I have downloaded the instructions for this tutorial and also 2 Python files. And I have opened those 2 files then and in Tony. So I have my Tony open and I have my 2 files in Tony ready to go. Okay, so what we're aiming to do is to have the microbit calculate the temperature in the room that we're currently in and send that temperature along the USB cable into the computer, where the computer's CPU will generate a virtual serial port and listen to that data. And then we want the Tony editor and the Python code in the Tony editor to throw that data out onto the screens. So we've got the microbit generating the data being uploaded into the computer, and then the Python in the Tony editor is going to read that data back out to the screen. So the first thing we need to do is step A, where we're going to the MakeBit editor. We are going to just do the first part of what I described there, which is getting the microbit to display temperature. So we need the forever loop, so the basic forever loop. And what we want it to do is to, just for the moment, show that temperature on the LED screen of the microbit. So I can do here show number, because temperature is a number. But I don't want to show the number 0, I want to show the number which is temperature, which is one of the inputs from the microbit. So in here I have a temperature variable, and I can put that in there instead of the 0. And then this part of the code I'm putting inside the forever loop. So forever I want to show the temperature in the room. Now currently this is being tested on the simulator. We can see the simulator here. And the simulator doesn't know what the temperature in the room is, of course, so it's got a dummy kind of temperature gauge here. And it's reading the temperature as 21, and you can see the digits 2, 1 appear on the screen. I can play with this temperature and you can see the numbers change, so it's just 2. Let's put it up to 36 so we can see the temperature changing. Okay, so at the moment that temperature is just going out onto the LEDs of the simulator. So let's download this code to our microbit. So to do that, we need to download here to our microbit. So I'm clicking on the 3 dots and picking download to microbit. And pops up with my file manager here, and I can see my microbit in the list. So I can click on the microbit and save. So it should be downloading it direct to my microbit. So I don't need this window open. I should see my microbit flashing as it's downloading. And here you can see my microbit, and it's reading the temperature in the room. The room I'm in is quite hot at the minute. It is 23 degrees. So 23 degrees, it's reading on my microbit. Okay, so what we actually want is not just to see the display on the screen, but we want the display to travel up through the USB to a serial port in the computer. Now, computers these days don't have serial ports, but the CPU is capable of producing a virtual serial port that we can direct the data to. The microbit has built into its USB port is a serial port built in on this end, but at the other end we need the CPU of our computer to create a virtual serial port. And the word serial, or the serial port, the idea is that the data will travel along the USB one bit at a time. Okay, so what we need to do is to go back to our make editor code and explain to the editor basically that we want to use the USB and we want to redirect serial information up that USB. So I'm just going to go back to my make editor now. Okay, so before the code begins, I need to redirect it. So I need to get a basic block of code, which is the onStart code. So this will happen on boot up as such, and it doesn't happen again. So it happens only once. And what we need to do is to go into our advanced options here, and we're looking for the serial options. So we have serial connection. And one of our options here is to redirect to USB. So I'm going to put that on the start. So now it knows, the microbit will know that I'm using the USB and I'm redirecting it, making it into a serial connection instead of a USB connection. Now, of course, I need to actually send the data up that connection. So I need to write a number along that connection. So under the serial menu, we have serial write number. And I'll plug that in there. So on serial write number. Sorry, I just put it up. Just rearrange the order here to match your tutorial. Okay, and what I want to write is not the number 0 again, but it's the temperature. So I'm just going to duplicate the temperature and put it in there instead of 0. So what this is doing is taking the temperature and writing it along the USB cable to the serial port at the computer. Now, when we write things like we're creating data, we tend to want to say when we've reached the end of the data. So we need to write a line, and we can add with that line a character that lets us know that we've reached the end. We don't have to put a character in, but we can do. So what I'm looking for is to write a line to say I've reached the end of the line. So serial write line. And I have no character in here at the moment, but what I would like to put in there is a semicolon, because we would like to ultimately maybe use comma. Sorry, that should be a comma, because we might ultimately like to use comma separated values. Okay, so one other problem that we have here is that the temperature could be read and written so fast. We can't deal with it that fast. So we'd like to put in a slight pause. So I'm going to go back to the basic and pull out the pause block. And I'm just going to pause for a fraction of a second, maybe 400 milliseconds. So go ahead then and download that code, revised code, to your microbit. So I'm saving to my microbit. I can see my microbit is flashing. And then the code will start running. I will see the temperature being displayed on the LEDs just as before, because the code still says to show the number. But also I'm having the temperature and a comma being wrote along the USB cable to the computer. I just can't see that happening. Okay, so what we need to do then is find out which port is being used by that USB cable. So the operating system of your computer is capable of creating multiple virtual ports. So we need to know which port it is using at the moment. And every time you plug in your microbit, it could be a different port. So if you find out your port today happens to be COM port 3, maybe, tomorrow it might become port 6, and day after it might become port 8. It could be all sorts of numbers. So each time you run this code, you need to check and see which COM port it is you're using. So I'm going to switch to the Tony editor. And one of the codes that we have in the Tony editor is called find serial port. And what this is doing is going through all the ports in my computer and listening to see which ports have something happening at them. And then it's going to print out the ports onto the screen that it finds. So I'm just going to run that code. And you can see here it's COM port 3 that my computer has found. But possibly you might find 2 or 3 ports, and you'll have to try to figure out which one is which. Okay, so COM 3 is the one that I need the computer to listen to, and then to pick up the temperature that's being sent up that communication port. So I have a second set of codes here in Tony. This one is called read serial. It is using the module serial, which is a module of pre-written functions and definitions that will listen to serial connections. So I'm setting up a serial connection. So this is using that library. I'm creating a serial connection, and I'm calling it SER. And then I'm setting the baud rate of SER to be 115200. And that is the maximum speed that the microbit can write along a serial connection. So essentially it means that the microbit can write 115,200 bits across a serial connection every second. So it's just letting the computer know what kind of speed it needs to listen at, because that's the speed that the bits are coming at it. I put in my COM 3 port here. You'd have to change this to whatever COM you found, whichever port you found. So I'm telling it to go listen to port 3 in my case, and I'm saying open up that connection. So this is the connection line has been opened to port 3. Then I have a while true, so this is my forever loop. I'm going to do this forever. So all of this indented stuff is going to just keep happening and keep happening. And what I'm doing is I'm reading one line at a time. So I'm reading a line along my connection, and I'm taking that, whatever I read, and turning it into a string. So a string data type. And then I'm storing that piece of data into the variable called data. So what I'm expecting to find here is the temperature, which was 24 earlier, or 23. I'm expecting 23 to be read into the data field here and to be stored as a string. And then I'm doing a little check that says, well, so long as the length of my data or the length of my string is bigger than 0, so long as I have some data, put that data out on the screen, so print the data to the screen. So a simple piece of code. I'm just going to run it now, and you can see what it does. So here we can see the data coming out onto the screen. So all of this line here, so B quote 2, 3, comma, space, 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 backslash R, backslash N, quote, all of that is one piece of data, that's one temperature, and then we reach the end of the line. So we have a new piece of data and a new piece of data and so on. And you can see the data is arriving with a little split second between them. That's because of the pause rate that I built in earlier. If I hold the microbit in my hand, so I've got my hand heating up the LEDs, which is where the temperature is sensed, you should see the temperature begin to rise. So you can see it's gone up there, 25, 26. So the temperature is coming in to the screen live from the microbit. So just a word on why this data looks so strange. So you should already be familiar with the print function in Python. And you should know that it has built into it a new line. So every time it prints out on a new line, which is why we're going from one line to the next. Okay, so the microbit is not just sending a new line. So the microbit is sending up along the serial connection. It's sending two things for its new line. What it's sending is a carriage return and then a new line. So if you think about the old typewriters and how you used to type on the old typewriters back way long time ago, the carriage return was when you had to go back to the beginning of the line, and a new line was when you had to move your page up a little bit so you can start typing onto the following line. So to get a new line, you actually had to do those two things. So that's what the \r and the \n represent. So a carriage return and a new line. The temperature is being sent in degrees Celsius. So where we're seeing 25 degrees, that's in degrees Celsius. But rather than sending it as the microbit's not sending it as a number 25, it's actually sending it as a string. So it's sending it with quotation marks around it. And then we have the Python code itself and what it chooses to do with a string literal, which is what we have here. So this is literally a string 25. The newer versions of Python will allow you to contain any Unicode characters. So we looked at Unicode a while back and we saw that they used various numbers of bytes to represent the data. But what we've got going on here is not a number of bytes, we have a number of bits. So we're sending our temperature as a string, but not a string containing Unicode characters. We're sending a string containing bits. So the B in front of the string, at the beginning of the string, that represents that the string that's following is being sent as 1 byte. So each character is represented by 1 byte, and not like the Unicode characters would be represented by a number of bytes.